All right, so this is 10.3, and it's the relationship between two categorical variables. So I think that this is going to kind of be a little bit of what I already talked about in the previous video, but that's good. It should be kind of a review for you. So recall the student's class subject preference data. So we talked about this same table yesterday with 10.1 and 10.2. So the principal says that males in the interview have a stronger preference for math than females. So we're going to see if why he says that. So that males have a stronger preference for math than females. He might say that because the number of males that like math is higher than the number of females. Okay, so, but the thing that he's overlooking, if he were to say that, is that the number of males in general is also higher. So that might not exactly be true. It might be a misleading fact there. We can determine the answer to questions like this by comparing conditional relative frequencies. Now, my conditional relative frequency as opposed to my joint relative frequency or my marginal relative frequency is conditional. It's based on certain things. So complete the conditional relative frequency table on the following page to determine whether males or females showed stronger math preference in the survey. So when we compare these, what we're comparing, it says to determine whether males or females showed stronger math preference. So what we would have to do to accurately compare this is compare the number of males that preferred math to the total number of males and to the total number of females. So 42 males, okay, that's for my table. Now remember I had 89 total here. I'm just going to go ahead and fill in these marginal frequencies because, well, we might use these in a second, but we need to know we're comparing males and females here. So 42 males out of the 89 males preferred math. So 42 out of 89, which gives you 0.47 or 47% of males preferred math. Okay, and 35 out of 60, because there's not 89 females, there's only 60 females. So 35 out of 60, which gives me 0.58 or 58% of females preferred math. So the principal said that males in the interview have a stronger preference for math than females. That would be incorrect. Okay, so it might ask us this later. I don't think it does, actually. But that would actually be incorrect because 58% of females prefer math and 47% of males prefer math. We could also go ahead and look at the English just while we're here. Why not? So 47 males prefer English out of the 89 and 25 females out of the 60 prefer English. So 47 out of 89 is 0.53 or 53%, and 25 out of 60 is 0.42 or 42%. And then there was 149 total, just to leave those marginal frequencies alone. So what percent of male students prefer math? Okay, so what percent of male students? This is what I was talking about yesterday. Because it says of male students, we're going to the male total. So 42 out of 89, which is 47%. And then what percentage of female students prefer math? So that's out of females, so 35 out of 60, which is 58% of female students prefer math. These percentages are called conditional relative frequencies. Make a conjecture as to why they are called conditional relative frequencies. So conjecture, remember, is just an educated hypothesis here. And they're conditional because they're not based on the total, but on one of the categories or one condition. So they are based on a condition or a specific category. Okay. When trying to predict a person's class preference, does it help to know his or her gender? Okay, I would say based on this data and this data alone, yes, because the percentages are different. Okay, based on the gender. Now, we are not stereotyping or anything else like that, but just based on this data, if we were trying to predict it, it would help to know his or her gender so that we would know the probability of whether they would prefer math or English or whatever. Okay. To evaluate whether there's a relationship between two categorical variables, we looked at the conditional relative frequencies. If there's a significant difference between the conditional relative frequencies, then there's evidence of an association, that's important, between two categorical variables. So is there an association between gender and class preference? So, yes, I would say yes, and you could justify this by whichever. I know the one we've been talking about is like females versus males that like math. So yes, 58% of females like math, but then 47% of males like math. So that is a pretty significant difference there. You could also argue that there's not a huge difference because they're both around 50%. So it's almost 50-50, so there might not be as strong of a correlation. You could argue that either way. So let's continue on to let's practice. So consider the high school students who were asked if they play video games. So here's the data in the survey. What percent of the students who do not play video games are female? So this is, again, what I was talking about before, where we're talking about the total percent of students who do not play video games are female. So I'm looking at this total and how many of those are female. So that would be 85 out of 145, which would give me 0.586 or 58.6%. Okay. Given that student is female, what is the probability that the student does not play video games? So student is female, so that means I'm looking at the total of females, which is 150, that the student does not play video games. Okay, there's 85 females who do not play video games. So that's 85 out of 150, which is 0.567. So I could have 0.567 probability, or if we want to list that as a percentage, that's 56.7% chance that they do not play video games. Of the students who are male, what is the probability that the students play video games? So I'm looking at my males. That's 129 total males. And I'm looking at the males that the student does play video games. Okay, so I'm looking at 69 out of 129 males, which gives me 0.535, or there's a 53.5% chance that the student does play video games. What percentage of the students who play video games are males? So this time I'm looking at the students who play video games. So I want you to notice the difference between these two. So of the students who play video games, that would mean I'm now talking about my total of 134, and it's asking what percent of these are males. So that would be 69 out of 134, which is 0.515 or 51.6%. 0.5%. Okay, moving right along, we'll do the beat the test and then be done. All right, freshmen and sophomores were asked about their preferences for an end-of-year field trip for students who passed their final exams. Students were given the choice to visit an amusement park, a water park, or a mystery destination. A random sample of 100 freshmen and sophomores was selected. The activities coordinator constructed a frequency table to analyze the data. What does the frequency 10 out of 55 represent? So 10 is here out of 55. So the relative frequency 10 out of 55 represents the number of freshmen. So the freshmen that prefer, so out of the 55 freshmen, 10 preferred the water park. Okay. What percentage of students who want to go to the amusement park are sophomores? So the students that want to go to the amusement park, there are 60 of them total. And the number of sophomores that want to go is 35. So 35 out of 60, which would give me 0.583 or 58.3%. Okay. What activity should the coordinator schedule for sophomores? So if we're looking at sophomores, it looks like sophomores want to go to the amusement park. And that's a pretty clear answer there. But if you want to know like a percentage of sophomores, then you could say 35 out of 45, which would give you 70.77777. So that's about 78% would like to go. Okay, that's kind of your justify your answer part of that. All right, if you have any questions, let us know.